Everyone, here I am Vadel Sagar. Welcome to the part number 6 regarding the potential energy of system of charges. Till that we are seeing the electrostatic potential. Now we split our now we shift to the our potential energy of system of charge. There is an one or two, three or up to so on charges are there. Which is called system of charge. So we are trying to find today potential energy, and at the end we see one example through which we can get an idea regarding the potential energy. So let's start. Potential energy of the system of charge. Consider a two charge. So we are starting from the general or simple case q1 and q2, whose position vector is r1 and r2 is looks like that, which is q1 and which is q2, and then r1 and r2 of the position vectors. Let us calculate the work done in a building up to the configuration. So how much work you need to do for the bringing the charges at r1 and r2. This line is more understandable in the next slide. This means that we consider a charge q1 and q2 it initially at infinite distance, and it's determine the work done to the external agency, how much work you need to do on the systems of the q1 and q2 to bring the charges at the given location at this r1 and r2. r1 અને r2 સુધી લાવવા માટે કેટલું કામ કરવું પડે, first of all that we have to find. This is called work done, and that will basic of it's what I'm trying to saying you, which explained nicely in the next slide. Where is okay, we have one q1 and q2 at infinite distance. That's why I'm putting at the corners of the slide. Suppose first charge q1 is brought from the infinity to the r1 distance. So this our q1 is brought from the infinite distance to the r1 distance, okay, from the origin. So the origin to the q1, now you are brought to the r1, which we seen earlier, which is r1 distance far, okay. There is no external field against which work need to do. See, where you brought your q1, there is nothing, another charge is there. It means there is no influence on it, so there is no need to do work. There is no work you have to do on the charge q1 to bringing from the infinite distance to the finite r1 distance. No need to do work, okay. But now when the task is, when q2 charge is bringing to the q1 influences place at r2 distance, we will see before that where our q1 is present, it's generate own potential, because we know any charge at the particular distance it has own potential expression. v1 is equal to 1 upon 4 pi epsilon 0 q1 upon r1. You can ignore the p point because r1 p, so this will be the origin will be the p should be, okay, but it is ignorable. So if you are writing in your notebook, so the v1 is equal to 1 upon 4 pi epsilon 0 q1 upon r1 you can write. This influence is there. Now this is a potential, something potential is there. What happened? Okay, so potential is there. So as you can able to see, there is a potential of influence of q1 is here somewhere. It is invisible potential is there for the q1. Now when you bring a q2 infinite distance to the your finite distance r2, infinite distance to the finite distance r2 from the origin, then the distance between them is r2 r12 becomes, okay, this will be. But when you bring your q1, there is no any other system is there, but when you bring q2, yes, q1 is present, so the its q1 potential is present. So you have to do work on the q2 for bringing from infinite distance to the finite r2 distance. This will depends on how much work you need to do. It depends on the what kind of q1 will be. Both are similar charge, both are opposite charge, depends on. But yes, the work done in bringing the charge q2 from the infinite distance to the r2 distance is this is important crucial point, q2 time potential of r1, q2 time of potential of q1. So this is the work done, mean wq2 is equal to 1 upon 4 pi 0 r1 into the Q1, which is potential. You can see this is the whole part. This whole the part I can replace with the V1. So this is the potential of the V1 time Q2. Just you multiply by. So I am defining something. Please note, work done on Q2 will be the charge which you bring multiply by potential of the present charge, which is Q1. Okay, so this is the potential of present charge and Q2 is there. Okay, this is a wonderful scenario through which you can able to understand. And at the end phase we get Q1 and Q2, which is far apart by the R12. Now onwards, whatever the calculation we do according this base. Since the electrostatic force is conservation, so their work gets stored into the terms of the, if you are doing the work on the system, so it will be stored as a potential energy. And this potential energy is of the Q1 and Q2 system is expressed by U. See, electrostatic potential is represented by V, but potential energy is represented by U, and that we are seen also in a previous second or third part. V is equal to U by Q, or U is equal to V time Q. So this is nothing but a V time Q. This is a V. Already we seen earlier in the previous slide also. But yes, it is a potential energy is equal to 1 upon 4 pi epsilon 0 Q1 Q2, whatever system number of charges you have, Q1 Q2 upon R12. There is a 2 R12, there is no square. That is an important part. So this is a, it is true for the all kind of charges if we have. Now let us see what kind of charge it can be. Q1 and Q2, it will be positive. It means both are positive charge. So that will be the repulsion always. Both are the positive side. The potential energy will be, so the expressions of potential energy V, U is equal to 1 upon 4 pi epsilon 0 Q1 Q2 upon R12. So if both are positive, then the potential energy will be positive. So this will be the acceptable. Electrostatic force is repulsive and positive amount of work you need to do. Now what happens? See, both are positive charge. Trying to imagine, because what I represent in a previous slide I cannot put in every slide. What I have infinite distance to bring a R1, infinite distance to the bring R2 distance, that image you should have keep in mind while I am doing this discussion. Okay, so suppose the Q1 is positive and Q2 is also positive. When you are bringing your Q2 charge, then it comes nearer to the Q1, the repulsion are feeling. So on the Q2, how much work you are putting on it, it will be the increase as you bring nearer to the Q1. So this is what I am trying to explain you. Electrostatic force is repulsion if it is both are similar kind of charge. If it is both are the negative, then it will be also positive. So this is a when it will be the similar charge. This kind of condition can be comes in when it will be similar charge. Both are negative, both are positive, and both are same, then will represent definitely. Represents it definitely. So done against the force to bring the charge from the infinite to the finite distance. So you have to do positive work. You need to do effort. Okay, this is the one conclusion. If it is both are negative, it means one positive and one negative, then obviously your answer should be negative of the potential energy. So the potential energy is negative. If it is one positive and one negative, you can take either words. Ultimately potential energy is negative, and potential energy is negative, it means the force of repulsion is attractant. So the whenever the expressions of potential energy you may get at the negative at the end, so that you can make a conclusion the force between them, it will be attractive. It means both are opposite charges, so it will be supportive to bring the charges nearer. Now exactly what I said in earlier, it will repel, so you have to do the more work on the system. But when you have similar kind of charge, the opposite kind of charge, they are attracting in each other, then it is supportive to bring nearer to it. So you need to do less work comparatively in earlier case. Okay, so this is we are extending our discussion to the two system, to the three body system. Between now onwards you have Q2, Q1 and Q3. You can able to see the respective distance are the between the Q1 and Q2 is R12. Respective distance between the Q2 and Q3 will be the R23. Respective distance between the R1 and R3 will be the R13, and then so on. You can able to understand, and it is also represented in this slide. So now onwards, the potential energy of the system of the Q1, Q2, Q3, which is respective of the other R1, R2, R3 distance. and to bring first charge q1 first from the infinity. So I am not representing that what the that animations of the charges bringing from that infinite to the some certain distance to the second will becomes, and then third will becomes. So this imagination, so that I mean there's animations you how to imagine in your mind to bring q1. Now I am bringing the q1 from the infinite distance. You can may get that idea, you can go back and then visual also. So there is no work you need to do because there is no influence already yet. Sorry. Next we will bring a q2 in the influence of the q1. So the q1 is already present, so due to q1 charge there is potential is already there. So the potential time of the what charges you bring, potential time which charge you bring, q2. So the potential time q, that much work you need to do. This is what we have. This is potential of the what already exists, which is q1, which is a potential of v1, and multiply by the what charge you bring. So this is nothing but the work done is q2 time v1 is nothing but the q2 is 1 upon 4 pi epsilon 0 q1 upon r1 to multiply by q2. Is it understandable? This is already we done. Now onwards we are extending our theory from this is the now the charge q1 and q2 already exist in the system. Its own potential of the two system is nothing but the superposition. They are superposition theorem they are obeying. Thus the potential of the one system, potential of the second system will be sum over each other. So this will be the v12 will be the 1 upon 4 pi epsilon 0 is common out, q1 upon r1 plus q2 upon r2p, as a p is a reference point from through which you are calculating. Okay, there is no matter 1 upon r1 1 upon r2 you can able to calculate. This potential is exist if you are now brings third party third charge, then they need to do work on the third charge to bringing this in a system. So this much potential time of the q3 which charge you bring. Okay, let us go and see what exactly the work done need to do on the q3 system from the infinite distance to the r3 distance you need to bring is q3 times that potential what exists, which is v12. So v12 you already know, just multiply with the q3 in a first term incorporating with the q3 and second term is also incorporating with the q3. It is a very easy step, you can go back and see also. This is already potential expression is there, just you multiply with the q3 inside, it will be the becomes a work done. So this is a q1 into the q3 and q2 time q3, that what we have here. Is it okay? And this is expressions of not q3 time v12, it is expressions of work done you need to do on the q3 charge. Okay, this is a what it is written. Sorry, the total work done in assembling the charge. Now three charges over. So now total work done. What work you need to do for the bringing the q1? 0. What work you need to do to bringing a charge q2? We seen in previous slide. What work you need to do on the q3 charge, which is represented here. So sum over the all the work. So the total work you need to do this much. U is equal to, which is nothing but the potential energy. U is equal to 1 upon 4 pi epsilon 0 q1 q2 upon r12. Okay. So this is the figure through which I can give explanation of its the potential between the q1 and q2. It is q1 and q2 r12, q1 and q3, and q2 and q3, because the all alternations are comes. Q2 and q1 is the potential will be same. So potential between q1 and q2 it will be same as the q2 and 1. Obviously potential between 2 and 3 will be the same as the 3 and 2. Okay, so this is the total work done assembling the charge from the given locations to the adding them all work done. So the potential energy of the system of charge will be the 3 is 1 upon 4 pi epsilon 0 q1 q2 r12 plus q1 q3. I can explain you. See, q1 q3 is there, which is a part is here, q2 q3 is there, it is here, and 0 plus actually the u is equal to 0 plus 1 upon this is, I will show you second work to bringing the charge, this one. See, second work is the q1 q2 term, so that this will be reflecting in the final result. You can see the first term will be there, q1 q2 is this. For the second charge you need to bring with that much work is This is the 4 pi epsilon 0 is common, so the q1 q3 is here and q2 q3 is here. So this is nothing but the summation of 0, second charge work done, and then third charge work done. This is what we have, the final result of the summation of alls. Is it okay? If you have confusion, you can make a comment on the comment section. If you like my videos, or if you like my representation, if you want some modification or the error, any kind of confusion, anything you need to suggest, you can make a comment so I can get an idea. You see, you love my work, and then you can inspire me to do more. Please. Okay, let's go for the further discussion. The final expressions of this u is independent to the manner which is configuring assembles. So you can able to see there is no information from where you bring a q1. See, in the final expression there is no from where you bring. There is no matter where the from the q1 comes. There is no matter from the where q2 comes. There is no matter from the where q3 comes. From where it is in this system, that will matter. The q1, q2, q3 is far apart by the r1 to r3 and r2 3 distance. This will matter in this system. You can able to see at the denominator will be the r1 2, r2 3, r3 1 and all that. Okay, so from where you bring doesn't matter. Which path they follow for the coming in the system, it doesn't matter. From where, from in which geometrical way in this assemble, this will matter at the end of equation. This is what we are getting informations from this potential energy systems. Let's go for the example through which we understand in a better scenario. So there is a 4 charge on a corner of the A, B, C, D, which is A is positive Q, B is negative Q, C is positive Q, you can able to see, and D is the minus Q. On the side whose edges are the length of small d, you can able to see. Okay, this is a 2.15 number A figure is there. What is A task? We will focus in the first A task, then we will go for the B task. Don't read B task. Find the work. So we have to find work to require to put together this arrangement. So same thing we have to do. We seen earlier for the two charge. Then we extending our theory or knowledge to the 3 charge. Now here we have 4 charge. There is no what I can say, there is no extraordinary things, brain push-ups and all that. No, just we extending 3 body to the 4 body. Now we have to know the distance between them. Yes, so what we will do, what we was do already, bringing first charge, second charge, third charge and so on. Here also for the same way, first we will bring A charge, then B, C, D, so on, and we will do calculation according it will be. So now first work needed to bring a charge Q plus to the point A. No need to do work. Why? Tell me. Because there is no other charges are already present. There is no B charge is present, there is no C charge is present, there is D charge is also not present, that is yet to come. Okay, so if there is no charge, forget it about this Q2. For the B task it will be for the B task. So the forgetting about for this A task, so there is no charges or influences at the A point, so there is no need to do work. Again, what we earlier also we discussed. Okay, so the bringing the charge A, bringing the positive Q at the point A, no need to do work. Let's go for the second. This is what we have. Second, work need to bringing minus Q charge at the B point when Q charge at the A point is already present. So already present charge is generate its potential. So the need to do work, don't see here, the need to do work is the potential of the system which is exists, which is Q1 time which charge you bring, which is Q2. So the Q2 time potential of 1, this is what we have. This is the Q2 is nothing but the minus Q for our calculations, and this is nothing but the potential by the first charge Q upon 4 pi epsilon 0 R, where R is your distance is D between them. Is it okay, dear? Yes. And just the simplification minus of the Q square 4 pi epsilon 0 and D. Is it understandable? Yes. Again I am explaining how much work you need to do for the bringing the charge minus q at the position of d from the first charge of q1, which is plus q, is potential by the first system, which a charge you bring, a I am saying because of the plus minus is there, so the a charge, potential of a charge is equal to q upon 4 pi epsilon 0 at d distance is the, so it will be the d time charge which you bring, which is minus q. That's why it will be this much work you need to do. Is it okay, guys? Yeah. So this is the charge time potential of the system. Third, so it will be now onwards the two charges already present, this and this. C we will bring, d yet to come. Work needed to bring minus q charge to d. Sorry. So this is the, so here here I did one mistake, but still I can able to explain you. Work needed to bringing the minus q charge, sorry. So this is the erase and write what I said you. Work need to bring a positive charge, this will be the positive, to C point when plus q on A minus q on B will be present. Two only present and third we will bring. So this is the, just this much you have to erase. And this is also now the charge C multiply with the potential of A and B. So this is the what charge you bringing, plus q, and what potential should be due to this charges, because the distance of this A and C will be how much? Oh, this is now chaos. This is d, this is d, then it will be the Pythagoras. D square plus d square is a 2d square, and the under root of the 2d square is under root d, under root 2 time d. The distance between A and D will be the 2 under root d will be the here. So the plus q to 4 pi epsilon 0 d under root plus 2, and minus q to this distance is d. So this will be minus q 4 pi epsilon 0 d. So this bracket is the potential representation due to charge A and B already present, while influencing of the C when you bring. The C will be the positive charge, it will be here. So this is the total work done you need to do. So the minus q square upon 4 pi epsilon 0 d will be common out. So in the first term nothing will be left. So the 1 minus 1 upon, sorry, this will be the term, there we are taking the common out, minus sign. So this is the 1 will be the left only these terms, and if you are taking minus common out, then minus will be here generate, this will be the here. So the 1 upon under root will be there. This is a simple math stuff, so you have to do at your notebook. Okay, I cannot solve the spoon feeding. Let's go for the fourth, where A, B, C charge is already present and D you are bringing. So work need to do for the minus q charge need to bring at the D point, while the already present A charge, B charge and a C charge. Then work done is the charge d time potential of A, B, C, D. The distance between A and D is d, distance between B and D is under root 2d, and distance between C and is d. So this will be minus q charge time, sorry. So this is a minus q time, this is a minus q time, plus q 4 pi epsilon 0 d, minus q 4 pi epsilon 0 d time under root 2, this is under root 2d distance, and the plus q time 4 pi epsilon 0 d distance. Just now onwards we have to do the minus time, minus q square will be common out, because q is there and q is the comes from this side. So the minus q, the first term is not minus, so it will be becomes minus. Second term is minus, so the minus will be left, so it will be the plus term, and so on. So the 1 and 1 is going to be 2, and minus 1 upon under root 2 will be there. Is it okay? So this is the sort of math steps you can do. So now whatever work you are able to need to do for the bringing the A charge, B charge, C charge and D charge, now sum over the all, due to 1 is the 0. So the first, okay, so the first charge, it will be the 0 minus q square upon 4 pi epsilon 0 upon d will be this common for the all terms, At the first it will be multiply will be going to be 0, so this is the bringing for the charge A. This will be time of Q, and this will be the term for the C point, and this will be the term for the D point. You can go back and see those expressions are there, through which I am just common out the minus Q square upon 4 pi epsilon 0 D and other all number terms in the bracket. This is very easy. Now if you just do the simplifications, you can see 1 1 and 2, so this is 1 1 2 2 2 4, and this with the minus and minus will be 2. Okay, common out, so LCM 1 plus 1 is 2, so 2 upon under root 2 will be the under root 2 only. You can do minus Q square, so the final work done is equal to minus Q square upon 4 pi epsilon 0 D, 4 minus under root 2. The work done depends only on the arrangement of the charge and not how they assembles. That conclusion already we made also. And now go for the B task. A charge Q2 is brought to the center. E is the sphere. This is what we have. Now charge, any charge you need to bring on the center, how much work you need to do, that we have to find. See the task. A charge Q0 brought to the center of the square, where 4 charges already fixed on the corners. How much work extra you need to do? Let us see the extra work necessary to bring a charge Q0 for the point E at the center of the system. So you can able to see there is a plus charge, there is plus charge, they are repelling each other. They are minus charge, they are minus charge, they are repelling each other. So their forces, their work are they cancelling each other. So let us read. The charges at ABCD is Q0 time potential effect of the E due to the charge of ABCD. Obviously this much work you have to do because the 4 charge already exists, so the potential is generated by the 4 charges is this much, but the potential generated by the ABCD is 0. Why? Let us read. The electrostatic potential at E is clearly 0. In a sense, potential due to the A and C will be cancelled out. You can go back and see their expressions is just plus and minus. By doing the due to the B and D potential also cancel out, the sum of all the ABCD potential will be 0. So the potential time of that charge which you bring Q0, so overall this multiply with the 0, that will be 0. So there is no work you need to do to bringing the Q0 at the center of the system. This is what we have to do today discussion. Thank you very much. Any kind of confusion or anything which you have to do, which you have to tell to me, you can contact me, you can comment, and everything you need to do here.